It is January 26th, 2026. On your screen, Artemis II, fully stacked, lit up on pad 39B. NASA's next major milestone is the wet dress rehearsal, the full cryogenic fueling test, targeted for no later than February 2nd. If that goes well, Artemis II could launch no earlier than February 6th, sending crew on a roughly 10-day trip around the Moon and back. But while Artemis II is real steel on the pad, the timeline for the next mission, the landing, still feels oddly hazy. In this episode, we'll walk through the logistics chain behind Artemis III, the bottlenecks on key hardware like the landing suits and Orion's heat shield, and then put a realistic probability score on a landing in 2027, 2028, or 2029. Let's start with the hard numbers. The rollout began the morning of January 17th. And what you're seeing here is the stack staged and buttoned up for that move. From first motion to pad arrival, it was a nearly 12-hour crawl over about 4 miles, topping out at just 0.82 miles per hour. That pace isn't drama, it's engineering. You don't rush 11 million pounds. Next milestone, the wet dress rehearsal, targeted for no later than February 2nd. And NASA's planning windows are already laid out. Launch opportunities open February 6th, then again March 6th, then April 1st, with an additional late April opportunity on April 30th. Now the contradiction. For Artemis III, the landing, some NASA materials still describe it as planned for 2027. But if you pull up NASA's Artemis III mission page today, the launch line is blunt: by 2028. That isn't a slip of the tongue. That's a schedule signal. So why the fog? If Artemis II is nearly at the finish line, why does Artemis III look like it could drift years? Bring in our systems architect. And as we look at this close-up of Orion hardware, every tag, every connector, every remove before flight streamer, remember, a lunar landing is the sum of 1,000 details that all have to be ready at the same time.
Because landing isn't just one rocket behaving on one day. It's an entire chain. Orion has to be certified end to end. The lunar suits have to be flight ready, and the lander has to prove it can get to lunar orbit and back safely. If any one link slips, the whole mission slips. And that's the real friction you're seeing. The physics and engineering of a multi-vehicle logistics chain don't negotiate with a political calendar. To understand the timeline, stop thinking of Artemis III as one heroic launch. It's a campaign, stepwise logistics, staged in orbit.
So SLS and Orion are the last move people see, not the first move that makes it possible.
Exactly. Before the lander can even think about the moon, you need a gas station in low Earth orbit, a propellant depot Starship. That depot goes up mostly empty. Then tanker Starships rendezvous, transfer liquid oxygen and liquid methane, and come home. Again and again, until the depot is topped off.
Let's talk numbers. How many tanker launches are we talking about to fuel one landing?
NASA won't lock a single number yet, but we do have a credible reference point. GAO's July 2021 decision described a conservative concept with 16 launches total, 1 depot, 14 tankers, and 1 lander.
14 tankers. Even at 1 a week, that's months of operations just to fuel up.
And now the physics problem. Boil off. Liquid oxygen and liquid methane are cryogenic. Given time, they warm, gas off, and you lose margin. So the depot is a thermos, not a vault. If the gap between tanker flights stretches, you're not just filling a tank, you're fighting a slow leak.
Meaning the requirement isn't just frequent, it's frequent without slipping.
Precisely. To keep the math happy, you're talking a tight cadence, days apart over a few weeks, and every attempt has to clear weather, hardware, range rules, and FAA licensing.
It is January 2026. We've seen Starship fly successfully. Flight 11 in October 2025 was a win. Doesn't that give you confidence?
It helps. But flying the rocket is step one. For Artemis III, the missing centerpiece is ship-to-ship propellant transfer. NASA's own technical guidance is blunt. Cryogenic transfer between independent spacecraft still hasn't been demonstrated. We've seen internal transfers on a single vehicle, but not two ships docking and moving, safely, on the order of 1,000 metric tons.
But there has been progress on the hardware side, right? The docking systems?
Yes, that's the quiet win. NASA and SpaceX ran full-scale docking tests at Johnson with more than 200 scenarios. What you're looking at is that test rig, so the pieces can work on the ground. The hard part is operations. Repeat rendezvous and docking, keep the cadence, manage boil-off, and do it without a major miss.
So, for a 2027 landing, that symphony needs to start playing perfectly. Basically, now.
Correct. If we don't get a convincing ship-to-ship propellant transfer demo in 2026, the math for a crude 2027 landing starts to fall apart.
Starship is the giant stainless steel elephant in the room. But even if a lander showed up tomorrow, we're still blocked by two other hard gates. On screen, suit on the left, heat shield on the right. We need a lunar suit that can survive the South Pole. And we need a heat shield we trust, because coming home means lunar return speeds.
Exactly. People think spacesuit and picture clothing. It's not. It's a personalized spacecraft with power, life support, thermal control, and comms, keeping one human alive in vacuum.
And there has been real progress. NASA and Axiom completed the first dual-suit run in the Neutral Buoyancy Lab on September 24, 2025. And Axiom says they finished the first uncrewed thermal vacuum test on November 20, 2025.
Progress is necessary, but certification is the hurdle. NASA's own milestones note Axiom is scheduled to complete critical design review in 2026, late if you're trying to land in 2027. And remember where these suits are going. Lunar dust can be under 20 microns. Fine, electrostatic, and abrasive. More like tiny shards than powder, because there's no wind or water to round it off.
Which means it gets into everything. Seals, bearings, joints. If dust compromises the suit's integrity, the mission is over.
Then add lighting. At the lunar poles, the sun stays near the horizon, about 1.5 degrees, so shadows are long, harsh, and persistent. That shadow diagram on screen is the problem in one frame. That becomes a real operations and vision challenge. Extreme contrast, hidden relief, and hazards that don't reveal themselves until you're on top of them. The suit has to protect you from abrasion, cold, and the simple physics of falling.
Now, the ride home. Orion. Artemis I came back with heat shield wear that didn't match pre-flight expectations.
Right. NASA traced it to gases generated inside Avcoat that didn't vent as expected, letting pressure build, crack the char, and shed material. For Artemis II, currently no earlier than February 6, 2026, NASA plans an operational fix. Shorten how far Orion skips between atmospheric entry and splashdown to limit time in the temperature range where the phenomenon showed up.
And Artemis III is still a crude lunar return entry. Even if the numbers look similar, the tolerance for surprises goes to zero.
Correct. Orion uses a skip entry technique, like skipping a stone, to manage range and loads. You're still talking roughly 25,000 miles per hour, and outside temperatures on the order of 5,000 degrees Fahrenheit. NASA's longer-term fix is material and manufacturing. Future heat shields for lunar return missions are being produced for uniform, consistent Avcoat permeability, so gases can vent instead of pressurizing. That kind of process change has to be validated end to end.
So, a suit aiming to clear CDR in 2026 and a heat shield transition that has to prove out, both on the critical path.
Starship may be the headline, but suits and shields are the fine print. You can't schedule your way around physics or qualify your way around missing data. If either isn't ready, we don't launch.
And that's the setup for the final verdict. When you stack Starship logistics on top of these two hardware gates, what does the timeline actually look like? Let's redraw the map.
The landing date isn't a dot on a calendar, it's a chain of prerequisites. Like the gear train on screen: Orion, Starship, suits. If one gear slips, the whole timeline slips with it.
So let's use the official record. Some NASA material still says 2027, but the Artemis III mission page says by 2028. Which one is it?
They're both signals, just different kinds. 2027 is an aspiration. By 2028 is the program telling you what it's willing to publish as a commitment.
Okay, perfect world mode. What has to go right to land in 2027?
3 green lights in a row. Gate A, Artemis II. It's on the pad now, with a launch window opening in early February 2026 and backup opportunities into April. It has to fly clean, and when Orion comes home, the heat shield and the life support data have to look boring in the best way. If Artemis II reveals a new thermal protection issue or a crew systems problem, you don't schedule that away. You redesign, requalify, and retest. That kind of loop eats months fast.
Understood. Gate B is the big one, the Starship Campaign.
Right, and even NASA's Safety Advisory Panel has used the word oversubscribed for Artemis III's stack of first-time milestones. For 2027, you need major demonstrations to work with enough margin that you're not repeating them for a year. On-orbit cryogenic propellant transfer, long-duration storage, a successful uncrewed lunar landing demo, and clean integrated ops in lunar orbit.
And finally, the hardware gap we discussed, the suits.
Gate C. Axiom's AX-EMU is in critical design now, and we've seen real testing, like the underwater runs on screen. But the hard part is closing qualification and certification, and then delivering flight-ready units on time. That schedule gets tight very quickly if anything fails late.
So if I ask you for a probability score right now, where do we stand?
Here's the verdict. 2027 is a stretch schedule. It's possible on paper, but it assumes unusually smooth progress with no major rework. By 2028 is the credible baseline because it matches what NASA is now publishing, and it leaves room for normal human spaceflight friction, especially on Starship HLS and suits, where independent reviews have repeatedly flagged how aggressive the plan is.
So we're going back. But physics doesn't care about political deadlines.
Exactly. Watch the tests, not the headlines. Artemis II's return data, Starship's prop transfer milestones, and suit qualification. That's what moves the timeline.
And right now, Artemis II really is on the pad. With the window opening in early February 2026 and opportunities into April, the next few weeks are going to be all about the wet dress rehearsal, the countdown, and the data. Thanks for watching.